Hi to everyone. I am Dr. VNSR Venkateswara Rao, working as Associate Professor in Institute of Aeronautical Engineering College from Hyderabad, Telangana. So today I would like to give the topic on the Electrochemical Series. So it is the series where it can explain the activity of the elements, especially the rate of the corrosion in the various process. So today I would like to give the topic and what are the components and contents involved in the electrochemical. Mainly the topics covered in this lecture is the definition, silent features, electrochemical series and applications. So these are the main features involved in the today's topic. So first one, what is the electrochemical series? Electrochemical series mainly involves in the arrangement of the elements in the increasing order of the standard reduction potentials is called the electrochemical series, and it is called as the activity series. Already I said that the electrochemical series is nothing but the rate of the reaction. The rate of the reaction mainly involves in depends upon the activity of the elements. Such activity is depends upon the standard reduction potentials. That means the elements are arranged in their increasing order of the standard reduction potentials. It explained by the electrochemical series. So standard reduction potential value shows whether the position of the equilibrium lies to the left or right to the hydrogen equilibrium. That means in the electrochemical series, the element of hydrogen is very, very important. The elements which are present above the hydrogen ions are considered as a oxidation potential. The elements which are present bottom of the series of the hydrogen nothing but a reduction potentials. That means where we move from top to bottom of the series, the standard reduction potentials will be increases. That means the element which is having the more reduction potentials will be higher stable element. So the elements that lost the electrons more easily have the lower reduction potentials, and those which accept the electrons more easily have the higher reduction potentials. That means the elements which are having the electrons more easily lost. That means oxidation. Oxidation means loss of electrons. Due to loss of electrons, the elements gets the positive charge, whereas the elements undergoes the reduction. Reduction means gain of electrons. So because of the gain of the electrons, the elements gets the negative charge. In the case of the oxidation, which is participant, reductant is participate in the oxidation, and in case of the reduction, oxidant is participated in the reduction. So that means because of the movement of the electrons, whether it may be loss of the electrons or gain of the electrons, finally the elements gets the respective polarity charge. So standard hydrogen electrode has a middle position in the electrochemical series, and its potential should be equal to the E0, that means equal to the 0. This is called standard electrode potential, and electrodes above the electrode having the reduction electrodes, and those below are the oxidation electrodes. That means depends upon the potentials develops on the element, whether we say that whether it may be reduction electrodes or oxidation electrodes. That means the center of the element should be nothing but a hydrogen, and its potential should be considered as a standard electrode potential should be equal to the 0. And what are the features of the electrochemical series? In the electromotive forces series, the elements having the higher positive reduction potentials are placed at the top. That means the elements having the higher positive potentials at the top. And the EMF series, the elements having the lower reduction potentials are placed at the bottom. That means negative. Bottom. So metal at the bottom is the most active metal, and non-metal at the top at most active non-metal. So this is the standard reduction potentials of the various elements. Already we said that the hydrogen which is present at the center, which is present at the center of the series, and the elements which are present in the above the hydrogen, nothing but it starts with halogens. And ends with the first group elements. First group elements, nothing but alkali, metals. That means initially what happens, the fluorine undergoes the reduction reaction with the help of the two electrons to get 2.87 volt reduction potentials. And the second one is the hydrogen peroxide. It is also undergoes the reduction and to get a 2 moles of the water molecule and get a potential nothing but 1.78 volts. And third one is the manganese O4 and undergoes the reduction with the 5 electrons to get a Mn plus 2 aqueous media and with 4 moles of the water molecule and get a potential nearby equal to the 1.51 volts. And next one, chlorine undergoes the reduction with the 2 electrons to get a 2 moles of the chlorine molecules to get a 1.36 standard reduction potentials. And next one is the chromate ions. Chromate ions gets a reduction with the 6 moles of the electrons to get a 2 moles of the chromium plus 3 ions with 7 moles of the water molecules to get a 1.33 standard reduction potentials. And oxygen undergoes a with reduction of the 4 electrons to get a 2 moles of the water molecules liquid to get a 1.23 volts. And next one is the chromium undergoes a reduction with 2 moles of the electrons 1.09 volts. And silver reduction with the only 1 electron because of the its valency to get a silver solid molecule, so to get a 0.80 standard reduction potentials. And next one is the ferric. Ferric means the oxidation state is Fe plus 3. That means generally iron is elemental form and it undergoes the oxidation iron plus 2 and further undergoes the oxidation to give a Fe plus 3. Fe plus 2 called as ferrous and Fe plus 3 is called as ferric. Whenever the oxidation state changes from iron to iron plus 2 and iron plus 3, we give the element name, that means ferrous and ferric. Initially it is called as iron. Okay, so that means again ferric also reduction with a single electron to get a Fe plus 2. Nothing but ferric converts into a ferrous and its couple potential is 0.77 volts. And oxygen will also undergo the reduction with the 2 electrons to get a hydrogen peroxide. Hydrogen peroxide to get a potential nearby equal to the 0.70 volts. And iodine, it is also one of the reactive element in the halogens to get a 2 moles of the iodine to get a 0.54 standard reduction potentials. And oxygen will also react with the 2 moles of the water molecule reduction with the 4 electrons to get a 4 hydroxy molecules and potentially 0.40 volts. And copper is also one of the D block element present in the 3D block, nothing but a first transition series will also get the copper metal to get a 0.34 volts. And tin, nothing but Sn4 plus reacts with the 2 moles of the reactions to get a Sn plus 2, that means undergoes reduction and get a potential nearby 0.15 volts. That means these are the elements which are having the above the series of the hydrogen and having the higher reduction, and having the higher oxidation potentials. And below the hydrogen, the elements which are having higher reduction potentials. That means we see the lead potentials. lead potentials undergoes the reduction with the 2 moles of electrons to get a lead solid, and we can get the minus 0.13 volts. And nickel is also one of the transition elements present in the first transition series, and undergoes a reduction with 2 electrons to get a nickel solid, and resultant potential is minus 0.26 volts. And cadmium is also one of the transition series elements, reduction with the 2 electrons to get a cadmium solid, and minus 0.40 electron volts. Again, iron, that means nothing but ferrous, undergoes the reduction with the 2 electrons to get a iron solid, and a couple potential is minus 0.45 volts. And zinc undergoes the reduction with the 2 electrons to get a zinc solid. So the couple potential of zinc is the minus 0.76 volts. So it is also one of the 3D group element, nothing but a first transition series, transition elements, D block elements. And 2 moles of the water liquid present in the physical media to get a reduction with 2 electrons to get hydrogen with 2 hydroxy molecules, and potential is the minus 0.83 volts. And aluminum, nothing but a third group element, undergoes a reduction with the 3 electrons to get aluminum solid, and couple potential is minus 1.66 volts. And magnesium, nothing but a second group element, alkali earth metals, undergoes a reduction with the 2 electrons to get a magnesium solid, minus 2.37 volts. And sodium, which is nothing but a first group element, alkali elements, undergoes a reduction with the single electron to get a sodium solid, and couple potential minus 2.71 volts. And lithium is also undergoes a reduction with the 1 electron to get a lithium solid molecule to get a minus 3.04 volts. So this is about the electrochemical series, which explains the activity of the elements according to their reduction potentials. That means the element which is having the more reduction potentials, having the more activity elements. That means the series planned according to the elements which are present in there, according to standard reduction potentials to get a stability of the elements. So in this series where we move from top to bottom, what happens? Starts with weak reducing agent to stronger reducing agent, or we move from bottom to top, what happens? Weaker oxidizing agent to stronger oxidizing agent. So this is about the electrochemical series are arranged according to the standard reduction potentials. So, and what are the applications and advantages of the electrochemical series? So there are so many applications and advantages of the electrochemical series. First one is that to predict the relative oxidation or reduction of the various electrodes. So that means the electrodes mainly classified into anode and cathode. Electrodes are mainly classified into both anode and cathode. What is the reactions happens at anode? Oxidation. And what is the reaction happens at cathode? Reduction. So anodic oxidation and cathodic reduction. So depends upon the elements which can act as, it may be either anode and cathode, that should be finalized by the electrochemical series. That means to predict whether the metal reacts with the acid to give hydrogen. Generally the metals which reacts with the acid to give hydrogen elements, that is also finalized by the electrochemical series. And to calculate the standard EMF of a electrochemical cell, and it is represented by E0. So that value is also finalized by the electrochemical series. And to predict the spontaneity of the reaction, that means some reactions occurs in the fast reaction, some reactions are less reactions. So that's we depends upon the spontaneity of the reaction. That is also predicted by the electrochemical series. And to predict the metal displacement in the some aqueous solutions, some of the metals will be replaced by the other metals. That should be depends upon the activity of the metals. That activity is also explained by the electrochemical series. and to calculate the EMF of an electrode or cell using the Nernst equation. So Nernst equation is also very important. It should be depends upon the concentration of the species and the mobility of the species. So that means depends upon the concentration and mobility of the species. Nernst equation is also finalized by the electrochemical series. To understand why the standard EMF of a concentration cell is 0, and to calculate the equilibrium constant of a cell reaction, equilibrium constant, and final one is the thermal stability of a metallic oxide. Let us explain each and every application with next slide. So first one is to predict relative oxidation or reduction of a various electrodes. Already generally the electrodes are classified mainly two types, anode and cathode. Anode and cathode. That means reduction potential is also known as a redox potential, oxidation or reduction potential, and is represented by EH. EH measures the tendency of a chemical species to acquire electrons and thereby reduce. That means reduction potential is measured in volts or millivolts. Units are volts or millivolts. Volts are millivolts. That means each species has its own intrinsic reduction potential. That means the more positive the potential, the greater the species affinity for the electrons. The more positive the potential, the greater affinity species for the electrons. Or more the species tends to be reduced. That means wherever the potential gets the positive species, that is nothing but a greater species affinity for the electrons, or more the species tends to be reduced. That means depends upon the the electrode potentials, always whether the electrons may be loss or gaining takes place. But always at anode what happens? Oxidation takes place. Always at cathode what happens? Reduction takes place. Anode always present in left side and cathode always present in right side. That means anodic oxidation and cathodic reduction. And the second one is to predict whether the metal reacts with the acid to give the hydrogen. That means the reaction between a tiny amount of hydrogen and oxygen in the air produces the characteristic pop sound. And this serves as a test for the presence of the hydrogen. That means because of the presence of the oxygen and hydrogen present in the atmospheric, with the presence of hydrogen, immediately it gives what happens? Pop sound. That means whenever the metal reacts with the acid, immediately it gives the presence of a sound. We can finalize the metal should be gives the hydrogen element. And third one is to calculate the standard EMF of a electrochemical cell. That means standard electromotive force, which is represented by E0. That means the electromotive force of a cell or EMF of a cell is the maximum potential difference between the two electrodes of a cell. That means E cell is equal to E right minus E left. That means the potential takes place at right side and the potential takes place at left side. At what happens right side? Nothing but a reduction takes place. What happens at left side? Oxidation takes place. That means reduction takes place at cathode and oxidation takes place at anode. The net potential gives a E cell potential. That means the electromotive force of a cell and EMF of a cell is the maximum potential difference between the two electrodes of a cell. It can also be defined as the net voltage between the oxidation and reduction of cell reactions. That means anodic oxidation and cathodic reduction. The EMF of a cell is mainly used to determine whether the electrochemical cell is the galvanic or not. What is the galvanic? That means the chemical energy converts into a chemical energy converts to electrical energy. So that is nothing but the definition of a galvanic. So based on the standard electromotive force or standard potential of the electrochemical cell, whether you can finalize that may be either galvanic or not. That means it may be either galvanic or electrolytic. That means if it is galvanic, the chemical energy converts into a electrical energy. If it is electrolytic, what happens? The reaction should be reversed. That means electrical energy converts into a chemical energy. And next one is to predict the spontaneity of the reaction. That means a spontaneous reaction is a reaction that favors the formation of a products at the conditions under which the reaction is occurring. That means the production of the formation of the products is very, very fast when compared to the general reactions. That is nothing but a spontaneous reactions. The best example for the spontaneous reactions is nothing but a combustion reactions. Combustion reactions. So combustion reactions means the reaction of the carbon with the atmospheric oxygen. That means the elements which are present in the carbon or fuel is the carbon plus oxygen gives a carbon dioxide, or H2 plus O2 gives rise to H2O. That means balancing the reaction, 2H2 plus O2 gives rise to 2H2O. So these two are the combustion reactions. That means the elements which are present in the mainly in the fuel elements. Fuel elements. So fuels are nothing but a solid, liquid and gaseous fuels. So out of the three fuels, the elements which are present in the carbon and hydrogen. Generally, solid fuels are coal fuels, liquid fuels are petroleum, gas fuels are LPG and CNG fuels. All the fuels containing the elements nothing but a combustion elements, nothing but carbon and hydrogen. So those are burning in the presence of the atmospheric oxygen, nothing but a combustion reactions. So those combustion reactions are the best example for the spontaneous reactions. That means combustion reactions such as these fire are the spontaneous reactions. Once the reactions begins, then it continues on its own until the one of the reactants fuel or oxygen is gone. So this is nothing but to predict the spontaneity of a reaction. To predict the metal displacement. So that means a metal can displace the metal ions. It means just below in the active series but not the above. That means the elements which are present in the activity series in the bottom of the elements. That means for example zinc is more active than the copper and is able to replace the copper ions from the solution. So once again we observe the series in the elements. So this is the series of the elements. What is the potential of zinc? What is the potential of the zinc? So zinc gets the minus 0.76 volts. And what is the potential of copper? 0.34 volts. That means the zinc having the possibility to replace the copper ions present in the solution. That means to replace the ions one metal ion by another metal ion. So that is also possible by the electrochemical series. Why? Because zinc having the more reduction potential, that means minus 0.76 volts, and copper having only 0.34 volts. That means it is comes under category of the to predict metal displacement reaction. A metal can displace the metal ions listed below. It is the more activity series but not the above. For example, zinc is more active than the copper and is able to displace the copper ions from the solution. That means initially the zinc having solid group and the copper is also present in the aqueous media. But zinc having the more standard reduction potentials compared to the copper. That's why zinc having ability to replace the copper ions and zinc is present in aqueous media and copper gets the solid media. So this is nothing but to predict the metal displacement reactions. and to calculate the EMF of an electrode or a cell using a Nernst equation. So that means the Nernst equation enables the determination of the cell potential under the non-standard conditions. That means it relates the measured cell potential to the reaction coefficient and allows the accurate determination of the equilibrium constants. That means including solubility constants. So that means it depends upon the solubility, whether the salt is partially soluble or completely soluble, depends upon the salt solubility present in the aqueous solution to determine the EMF of a electrode or a cell using Nernst equation. That means the concentration of the species and mobility of the species and solubility of the species is very important for the determination of the Nernst equation. That means the Nernst equation enables the determination of the cell potential under a non-standard conditions. That means it relates to the measured cell potentials, the reaction quotient, and allows the accurate determination of the equilibrium constants. That means including solubility constant. And to understand why the standard EMF of a concentration cell is equal to 0, especially standard hydrogen electrode. Standard hydrogen electrode. That means the standard electrode potential commonly written as a E0 cell. E0 is represented by standard electrode potential of a concentration cell is equal to the 0 because the electrodes are the identical. But because the ion concentrations are different, there is a potential difference between the two of cells. So one can find the potential difference via Nernst equation. That means one is the reference electrode, and second one is the indicator electrode. One is the reference electrode and second one is the indicator electrode. So because of the potentials and the reference electrode fixed at a constant position, and the indicator electrode explains what are the potential present in the analyte solutions. So the difference between these two electrodes get a standard electrode potentials that can be determined by the Nernst equation. And next one is to calculate the equilibrium constant of a reaction. Equilibrium constant is represented by capital K, and it is the ratio between the concentration of the products with the concentration of reactants. So that is nothing but a equilibrium constant of a cell reaction. The equilibrium constant of an electrochemical cell redox reaction can be calculated using the Nernst equation and the relationship between the standard cell potential and the free energy. That means depends upon the cell potential with the free energy. That means whenever the reaction takes place, there is a must and should change in the free energy. So whenever the free energy changes, the equilibrium constant also changes. That means the equilibrium constant should be directly proportional to concentration of products and inversely proportional to concentration of the reactants. And thermal stability of the metallic oxides. That means the thermal stability of the metallic oxides decreases from the top to bottom in the electrochemical series because the electropositivity decreases from the top to bottom, and the thermal stability of the oxide also decreases from the top to bottom. So that means depends upon the electrochemical series, we can explain the thermal stability of the metallic oxides. That means whenever the temperature rises, some of the metallic oxides will be less stable, some of the metallic oxide will get more stable. So such conditions will also explained by the electrochemical series. That means it is nothing but a thermal stability. So metallic oxides especially decreases from the top to bottom in the electrochemical series, where we move from the halogens to alkali and alkali earth metals, and electropositivity decreases from the top to bottom, and the thermal stability of the oxide also decreases from the top to bottom of the series of the elements. So this is nothing but the applications of the electrochemical series. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.